Welcome to the Sports Science Hub's guide to everything you need to know about the fundamentals of linear motion. We will help you understand the difference between scalar and vector, Newton's 3 laws of motion, and how to understand impulse graphs. Let's get started. Linear motion is essentially when an object moves in a straight line, such as a sprinter running on a straight track. Linear motion can be split into two different quantities. Scalar quantities are described by a value only. No direction is included. For example, distance is a single value between 2 points, such as 100 meters. Mass is a single value of a quantity of matter, such as 90 kilos. And speed is a single value of the rate of change of distance, such as 30 meters per second. For example, speed equals distance over time. Whereas vector quantities are described by values and direction. Instead, we now have displacement, which is the shortest distance from start to finish of a movement, such as the crow flies. Weight, which is the force a mass feels due to gravity. And velocity, which is the rate of change of displacement. For example, velocity equals displacement over time. If we use our sprinter as an example again, they will not be able to run at the same speed from start to finish. Acceleration is the rate of change of velocity. Deceleration is negative acceleration. Acceleration can be calculated by taking change in velocity over time. In order to further understand linear motion, we have to take a look at Newton's laws of motion. It is these 3 laws that explain everything we see around us, such as why things move the way they do and why objects are just not floating around all the time. Law of inertia. An object will remain at rest and will require a force to move it. Once moving, it will keep going unless a force changes its motion. For example, a football will remain at rest on the floor until somebody kicks it. Law of acceleration. An object acted upon by an unbalanced force will accelerate in the direction of the force. For example, when hitting a ball, the force of the racket swing causes the ball to accelerate in the direction of the swing force. The amount of acceleration is determined by the mass of the object and how hard the player hits it. Force equals mass times acceleration. And law of action and reaction. To every action, there is an equal and opposite reaction. For example, a high jumper exerts a downwards force into the ground, whilst an opposite force lifts them up. Or a swimmer pushes water away whilst being propelled forward. Momentum is a concept off the back of Newton's second law, which can be calculated by taking momentum equals mass times velocity. A 100-kilo rugby player, or NFL running back for example, will be much harder to stop running at speed compared to a 50-kilo jockey or marathon runner. Impulse is another concept derived from Newton's second law. An impulse is when a force is applied to an object for a certain amount of time. For example, a bat striking a ball. If you follow through during the swing, you would increase the amount of contact time with the ball, which would increase the impulse, and therefore the ball would leave the bat with greater velocity. Impulses are commonly shown in force time graphs. As a sprinter accelerates over the first 20 meters, there is a positive impulse. When the sprinter reaches constant velocity during the middle of the race, there is 0 impulse. And as the sprinter decelerates over the finish line, there is a negative impulse. Thanks for watching. If you liked what you saw, then please help others find our videos and hit the like button below and subscribe to our channel now. You can also find us on Facebook, Twitter and Instagram. Don't forget to also visit our website www.sportsciencehub.com for more videos on everything you need to know about sports science. See you soon.